In this video, I am going to discuss general pivot point rotation. Also, I will discuss relevant composite transformation metrics. First, let's try to understand translation. This is our y-axis and this is our x-axis. Here we have the origin. Now we have a point with coordinates x, y. This point is moved along the positive direction of x-axis by the amount of dx, and again along the positive direction of y-axis by an amount of dy, and it comes to the position x1, y1. So now x1 means x plus dx, y1 means y plus dy. So if we have this point, we can represent this point by a matrix like this. Its type is 3 cross 1. Now you have to, here you have to get x1, y1, 1. This point we represent by a matrix of type 3 cross 1. Here we have to find a matrix where the multiplication of these two matrices give this matrix. So, in order to be able to multiply these two matrices, the type of this matrix must be something cross 3. And here number of rows is 3. Therefore, here it should be 3. Now we have to find a 3 cross 3 matrix. So if we put 1 0 dx, 1 0 dx, so you will get x plus dx to x1 like this. Then if we put 0 1 dy here, you will get y plus dy for y1. Now finally 0 0 1, so you will get 1 here. This matrix is called the translation matrix, and we represent it like this: t dx, dy. Then let's discuss about the rotation. Rotation, this is our y-axis, this is our x-axis, and we have the origin here. Actually here I am going to discuss the rotation around the origin. Now we have a point with coordinates x, y. this point is rotated around the origin in anticlockwise order by an angle of theta. So in this way, this point is rotated around the origin. So we will get x1 comma y1 now we can mathematically using mathematics we can get x1 from x and y. Therefore, x1 is equal to x cos theta minus y sin theta. y1 is equal to x sin theta plus y cos theta. This matrix represents this point. Now this matrix represents this point. So we have to find a matrix here. The multiplication of these two matrices should be equal to this. In order to be able to multiply, the type of this matrix must be something cross 3, and number of rows in this matrix is 3, therefore here we have 3. Now in order to get the value of x1, so here we have cos theta minus sin theta 0. Therefore we will get x cos theta minus y sin theta. Here you should get sin theta cos theta 0. That means x sin theta plus y cos theta. Now here we have 0, 0, 1. You will get this one. This matrix, we call it the rotation matrix. Actually the rotation matrix around the origin, and we represent it using r theta. Earlier I discussed how to rotate around the origin. Now let's see these are the two axes and the origin. Now let's say we have point x0 comma y0, and we have another point x comma y. Now we need to rotate this point around this point by an angle of theta in anticlockwise direction. So we have this one, and by an angle of theta in anticlockwise direction So we get x1 comma y1. Now this point x0 comma y0, we call this point the pivot point. So we 3 cross 1, this matrix represents this point, and this matrix represents this point. So we need to find the matrix so that the multiplication of these two gives this matrix. So now here, in order to be able to multiply, the type of this matrix must be something cross 3. Here number of rows is 3, therefore here we have 3. It is a 3 by 3 matrix. We have to find this. Now here we have x, y, 1, 3 cross 1. Now let's say we have x0, y0 here, this point. This matrix represents this point. So if we use translation matrix, 1 0 minus x0, 0 1 minus y0, 0 0 1. So multiplication of these two matrices will give 0 0 1. This matrix represents the origin. Therefore, if we apply in other words, to this point, if we apply this transformation matrix, this point comes to here. This one comes to here. So what happens? Here if we use xy instead of x0, y0, so x now so this point will come to here. This metric represents point 1, this point. Now we can rotate. Now we in previous situation we could derive a matrix for rotation around the origin. Therefore now this point That means this matrix represents this point. This point now we can rotate around the origin by an angle of theta. Point 2. So multiplication of these two, this is a 3 cross 3 matrix, will give another matrix, and this represents point 2. This one, this is the angle theta. Now again, let's say we put something like this: x naught 0 1, y naught 0 0 1. If we had origin here, that means if this one was 0 0 1, if this one was 0 0 1, then if we apply, if we multiply this matrix with this, if it represented the origin, then what happens? You will get this point. That means this point will move to here. Therefore, now this point will move to here if we apply this matrix. Therefore, now multiplication of these two matrices will give a matrix that represents what? This one. Okay, that means you will get x1, y1. Anyway, you will get this, and here you will get value of x1 and value of y1. So in this way we can, therefore here we get x1 y1 1, 3 cross 1. This is a 3 cross 3 matrix. Now consider this one. We can multiply these three matrices. Then x1, y1, 1, 3 cross 1. If we multiply this, we can get something like this. Cos theta minus sin theta minus x naught cos theta plus y naught sin theta plus x naught sin theta cos theta minus x naught sin theta minus y naught cos theta plus y naught. Then here 0, 0, 1. This is a 3 by 3 matrix. So you can multiply these three matrices and then you will get this matrix. Now here we have x, y, 1, 3 cross 1 matrix. Now this matrix, we call this matrix the composite transformation matrix for general pivot point rotation. Now you can see if we put this point here, you will get this one when we multiply by this matrix. So that's all about general pivot point rotation. Thank you for watching.